Hello everybody, this is the notes for Advanced Geometry section 10.3. We haven't done these notes in a little while online, so just a little quick reminder. Utilize the pause button to copy some stuff down into your notes. Use the rewind button to hear some things again. I'm going to try to cruise through these properties pretty quick, so pause it, rewind it, do that kind of thing. Take advantage of the technology. All right, so for section 10.3, properties of chords. Remember, a chord is just a segment with its endpoints on the circle. So in this picture here, chord AB, chord CD. The first property says, in the same circle or in congruent circles, so remember it means the radius is the same, radius equal for congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So really what we're talking about here is because chord AB is congruent to chord CD, arc AB, that minor arc here, going from endpoint to endpoint of that chord, will be congruent to arc CD, that minor arc, from C around the circle to D. So the reason this is true, remember, an arc measure is based off of the central angle. So I'm going to draw in the center of the circle. I'm going to draw in a radius to B. I'm going to draw in a radius to A. Radii are congruent. Then I'm going to do the same thing, a radius to point D and a radius to point C. Those are the same radius. So if you look at these two triangles are congruent because of side, 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 which means corresponding angles are congruent. Because that's the central angle, because that's the center of the circle, these are central angles, so that means the arcs are equal, because the central angles are equal to each other. So that's the Y part of this. Congruent chords means the minor arcs are going to be congruent to each other. All right, next one. Up top, if one chord is a perpendicular bisector of another chord, then the first chord is a diameter, meaning you're going through the center of the circle. So, a perpendicular bisector, we got to think back towards the beginning of the year to one of those properties. Any point on a perpendicular bisector, it's equidistant from the endpoints. So what that means is, if I put a point here, connect it to C, and I connect it to D, because this is a perpendicular bisector, these segments are congruent. So that's telling us we got to be going through the center of the circle. To have this point be the same distance from C as it is from D, we have to be going through the center of the circle. All right, which makes chord AB a diameter. All right, next one on the bottom. If a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So basically, we're kind of changing this problem around a little bit. If we have a diameter, there's the center of the circle, and it is perpendicular to a chord, what that tells us is the chord gets cut in half. So those two segments are going to be equal to each other. And just so I can name them, arc AB will be congruent to arc BC, like it says. The chord and its arc is being bisected by that diameter. And why this is true, again, it can go down to congruent triangles. If we draw in those radii, it's forming two congruent triangles, and so the central angles are going to be equal right here and right here, so the arcs are congruent, and that chord got cut in half because, again, corresponding parts. All right, next one. In the same circle, or in congruent circles again, two chords are congruent if and only if they are equidistant from the center. So if this is the center of the circle here, point, we'll call it circle E. If they're equidistant, now that term, equidistant, it means two things. It means congruent with these tick marks here, but it also means you got to be going perpendicular. So from the center, if you go perpendicular to a chord, perpendicular to another chord, and it's the same distance from the center, that means chord AB will be congruent to chord CD. all right, in the same circle or in congruent circles. So there's that property. All right, like I said, I was going to fly through those properties. Now, just some example problems. I'm not going to do all of them, but I'm going to just kind of go through and talk about the thought process for these things. It says, find the measure of the given arc or chord. So in question number 1, we're asked to find the measure of arc BC. That's this arc here. Now, you'll notice chord AC is congruent to chord BC. If the chords are equal, so are the arcs. Now, if you look at this full circle, that's 360 degrees. We know the 116. So if you subtract those two, 360 minus the 116, that puts us at 244. I'm just doing mental math. If I make a mistake, just roll with it. So that leaves us, this 244 is really the measure of arc ACB, that major arc. But because chord AC and chord BC are equal, arc AC and arc BC are also going to be equal. So we just need to cut that in half. Measure of arc BC will be 122. All right, question number 2. We have 4 congruent chords in here. So this arc will be equal to this arc, will be equal to that arc, will be equal to that arc. That's just 360 divided by 4, which is 90 degrees. That is each of those individual arcs. So make sure you're paying attention to what you're looking for. Arc LM is just one of those arcs. So that's our answer. And what I mean by that is, what if you're asked to find the measure of arc JL? Well, JL is 2 of those 90 degrees, so the answer there would be 180. So just pay attention to the little details of the question. All right, real quick, number 3. The question is, what is the length of segment QS? Because of this center point, we are dealing with a diameter. It is perpendicular to a chord. One of those properties is when a diameter is perpendicular to a chord, the chord gets cut in half. So that means Q, well, basically there's no name for it, but that little part, Q to here, is 11. That's 11 from this point over to S. The question is, what's QS? It's 11 plus 11. All right, number 4 is very similar to number 1. Number 5, arc PQR. So again, with this problem, this is a diameter because it's going through the center of the circle. It's perpendicular to chord PR. When a diameter is perpendicular to a chord, the chord gets bisected, and so does the arc. So arc QR is also 40, but this question is asking for the measure of arc PQR. So 40 plus 40, 80 degrees. All right, for this page, same idea, same thought process. On the previous page, we were basically just given numbers and asked to find it. Now we're given expressions, so we're setting those things up. If we look at question number 7, again, we have a diameter. It's perpendicular to a chord. That chord is getting cut in half. So 3x plus 16 equals 12x plus 7. The question is solve for x. So there's your equation to do that. Question number 8. We haven't used this property yet in examples, but we got a center of a circle. We have chord AB, chord DC. We're going perpendicular to that chord a certain distance. We're going perpendicular to this chord the same distance. So these two chords are equidistant from the center, so that means the chords are equal. Okay. The rest of these are fairly similar to this. Number 12 is kind of a trick question. Those are just radii of a circle. So these two expressions are going to be equal to each other. All right, same idea there for number 8. I think we just did that one. Determine whether PR is a diameter of the circle. All right, so for this one, is PR diameter? It is cutting a chord into 2 equal parts, but we don't know it's perpendicular. If PR was perpendicular to QS, yes, but we don't know, so no. And the idea of that is, I mean, we could have a chord PR coming in right there. It's cutting that chord QS into two equal parts, but it's certainly not perpendicular, and this red one here is certainly not a diameter. Okay, so it's got to be both. It's got to be cutting this into two equal parts, and it has to be perpendicular. We don't have both, so the answer is no. For number 14 here, is PR a diameter? We got the perpendicular part, but we're missing the part of it being cut into two equal things. So again, the answer would be no. All right, that's the notes. Your sub tomorrow will have the worksheet. Do your best. Ask questions when I come back on Wednesday. Bye.